Testing and calibrating three-phase energy meters can be difficult, time-consuming, and thus costly. This is mainly due to the process required to fully test and verify the output of the meter. Energy meters, almost without exception, use a technique of generating pulses to indicate the amount of energy they have measured. Each pulse represents a specific number of watt-hours. Calibrations are traditionally performed using a reference measurement technique where a known amount of energy is simultaneously supplied to a reference meter and the meter under test. A reading from the reference meter is then compared to a reading from the UUT and the error is calculated. Three separate pieces of calibration equipment are required to complete this task. 1. A power supply that can provide 3 phases of voltage and current. 2. A 3-phase reference energy meter. And 3. A device for counting pulses both from the reference meter and the UUT, which then compares the two counts. As you can imagine, this is a lot of work to make sure that each piece of equipment is connected and communicating properly. How can this process be simplified, you may ask? The answer is the Fluke Calibration 6003 3-phase power calibrator. The 6003A was designed specifically for testing energy meters, and it makes calibrating and testing them simple. It combines all 3 necessary pieces of equipment into one simple, easy-to-use calibrator. The 6003A has 4 energy testing modes that allow you to test a variety of energy meters. Those modes are free run, counter, timer, and packet. All of these modes provide a way of easily configuring a test to output a precise power level. In return, the energy meter will provide a watt-hours measurement. Let's discuss these modes in more detail. One of the biggest pain points in energy meter calibration is determining what the correct frequency of the meter output is, based on the energy it is measuring. For reference, the frequency is also commonly referred to as the meter constant, and matching the meter constant to the calibration system can be confusing. The 6003A has a mode called free run that simplifies this process and allows you to quickly change the test parameters while continually monitoring the meter's output to verify that the correct meter constant is being used. The deviation between the meter and the 6003A is continuously calculated and shown as a percentage on the display. To demonstrate, I've configured a test for 200 volts AC, 1 amp at 50 Hz. Since we'll be measuring the pulse output of the meter, I've connected the pulse output of the meter under test to input 1 of the 6003. I need to set the meter constant or frequency to match the meter's pulse output, which for this meter is 6,400 pulses per kilowatt hour. To start the test, I will push operate and the test starts. The 6003 outputs 200 volts 1 amp into the UUT. In other words, it delivers 200 watts to the meter. The 6003A receives the pulses back from the meter and based on the meter constant expects an exact frequency of the pulses. The 6003A continuously shows the deviation between the measured frequency and expected frequency as a percentage. The meter we are testing is a 3-phase class O2 energy meter, and based on this measurement, the meter is well within that specification window. This mode is useful for troubleshooting setups and is not recommended for the most accurate and repeatable energy calibrations. For that, we recommend the counter mode or timer mode. The reason counter and timer modes are more repeatable methods to test energy meters is that they either count a predetermined number of pulses from the meter under test, or they test the meter for a predetermined amount of time. Both the counter and timer modes have a warm-up feature for the UUT. This counter method is also known as rolling start method because of the warm-up feature. To demonstrate, I've configured this test for 200 volts AC, 50 Hz, and 1 amp. If I use the counter mode, the 6003A lets you specify the warm-up pulses from the meter under test. If I were using the timer mode, I could set how many seconds I want the warm-up time in the test to run for, as I show here. For this demonstration, we will use the counter mode. I will set the test to receive 10 pulses as a warm-up and run for 100 pulses. In other words, the 6003A will apply power to the UUT, wait for 10 pulses from the UUT, then test until another 100 pulses have been counted. I will now push the operate key to start the test. The 6003A starts to count energy pulses. After it has received the amount of warm-up pulses prescribed, the test will run for the amount of pulses set in the test. Counting is finished after the set number of predetermined test pulses is reached. The display now shows energy delivered during the set number of test pulses and displays the deviation from nominal as a percentage. I would like to point out that the 6003A voltage output stayed on and the product is still in operate. This was on purpose, because many energy meters rely on the line voltage to power the meter. This is a configurable option and allows you to keep the voltage on so the meter doesn't power off. This is very handy because the next time you will run a test at the same voltage, you may need 2 amps instead of 1. You simply change the current output on the 6003A while the voltage output is still active and powering the UUT. In some cases, you may have to test an energy meter without a pulse output. In this case, the simplest method is to do a timed energy test where you compare the expected value to the measured value on the energy meter. This can be done using the packet mode. In packet mode, which is also known as dose mode, the power from the output terminals is timed to deliver a set amount of energy to the meter under test. This method is not as accurate as the other methods because the startup time of the 6003A is not synchronized with the UUT, but it is the simplest. To test the accuracy of the meter, the amount of energy shown on the display will be compared to that of the energy meter and the deviation must be manually calculated. Using this energy meter, I will run an example packet test which will let me determine if it is measured and reported the correct watt hours. I've configured my test for 200 volts, AC, 50 Hz, and 1 amp. I'll set the packet time for 200 seconds. I've also prepared the meter to start measuring from 0. I will now push operate and you will see that the test starts and the countdown begins. You have just seen how easy it is to set up a calibration for a 3-phase energy meter. Whether you are calibrating or troubleshooting energy meters, without question, the 6003A greatly simplifies the task and provides confidence in your results. For more information on this product, go to www.flukecal.com.